Chapter 8, Section 2, we are adding, subtracting rational expressions. So let's work through a couple things. You should see a lot of similarities to things you've learned a long time ago, but unfortunately, you probably get rusty because of calculators. So let's recall. Back in the good old days, if you had 4/15 plus 7/12 and are asked to do this problem, you have to have a common denominator to add or subtract. You have to have that common denominator to add or subtract these things. So, in your head, hopefully, you break these things down and find the least common denominator, the LCM or LCD, least common multiple, least common denominator. So 15 breaks down into 3 times 5. 12 breaks down into 2 times 2 times 3. What am I using there? I'm using prime factorization. Prime factorization. So our LCM or LCD is going to take everything without everything once, I should say. So repeats only count once. We'll take 2 times 2 times 3 times 5. There were 2 3's here. We only use the factor once. 4, 12, 60. That's the long version of it, but you're going to need that to help you out with expressions, algebraic expressions, as we go through these. Let me see, that doesn't look all that clear, does it? There, that looks a little bit better. All right, so that means in your head, when you're doing all this stuff, we got to have an LCD of 60. That means we got to get these things become 60. So I got to multiply that by 4, what you do the bottom, got to do the top. Got to multiply that by 5, what you do the bottom, you got to do the top. So as we're working through this, we now get 16 over 60 plus 35 over 60, which allows us to add things together. 51 over 60. Remember, denominators don't change. That's the whole purpose of getting them to be the same. We'll do this, and then it's a fraction. Can you reduce? And the answer is yes. So we look and reduce them both by 3. So 17 over 20 will be our final answer as we work through that problem. Least common denominator, least common multiple. However you want to do it. So let's practice a little bit of this and how to find these least common denominators, least common multiples as we do this. So, an example. I would like you to find the LCM of the following. I'll give you 6, 8 to the third B, and 15 AB squared. Now somebody's going to say, why can't I just multiply the things together? You can. Finding the least common multiple or least common denominator lets us set these things up so we don't have to reduce in the end. That's what it is. Try not to reduce in the end. So our 6, we get 2 times 3, and our 15, 3 times 5. Now, what do we do with variables? Well, you can do it a couple different ways. You can write all these out, a times a times a times b, a and then b times b, or use this rule. We're going to use the highest power of, there we go, the variables, or of the variables, or each variable. I'll put each. So there's 25 different variables in there. We're going to use the highest power of each individual variable. Each individual variable. So we look. Here's an a cubed. Here's an a. Greatest power. Here's a b. Here's a b squared. Greatest power. And we do our prime factorization. Use the factor. There's a repeat, so we'll use it once and use the factor. So as we work through this, we have 2 times 3 times 5, so 30. Biggest power of a is a cubed. Biggest power of b is b squared. All right, try this one now. As we work through here, look at the difference that I've given you here in this example. Again, still want you to find the LCM. But this time, I'm going to give you y to the fourth plus 8y cubed plus 15y to the second power. So that trinomial represents some number. And we'll go y squared minus 3y minus 40. Again, that trinomial represents a single number. So what do? In a situation like this, notice what we were doing on the other ones. We were factoring them down. Same thing. Factor. Our factor patterns are coming into play. Got to remember them. So look, I got 3 terms here, but notice they all have something common. Factor that out. So we're going to go a GCF on the first thing. So we'll get y squared out of that, leaving us with y to the second power plus 8y plus 15. Before you move on, remember, it's been a little while since we factored, but please remember, sometimes a factoring pattern opens up another pattern. We've got ourselves a quadratic trinomial in here. Can I get 2 factors of 15 that add up to be 8? The answer is yes. So as that thing factors down, we still have this factor out here of y squared, and then 3 times 5. So I'll get a y plus 3 and a y plus 5. Now that thing's factored completely. Go over here. Our second number, trinomial, no GCFs. So can I factor it as a quadratic trinomial? Are there 2 factors of 40, negative 40, sorry, sign's important, that can give me a negative 3 when I combine them? Well, I think a negative 8 and a positive 5, check for the product, check for that. So they give us a y plus 5 and a y minus 8. So now, what do? Just like we did with the other ones. We take the factors, and we take the greatest factors of if there's repeats. So let's look. How many factors do we have? Well, there's 1, 2, 3, 4, 5. Now, that's all I did was count 5 factors. Are there repeats in this? Yes. Do we use the repeats? We'll go back to here. At 4 factors. Repeats we'll only use once. So, I'm going to underline the factors that we're going to use. There. Y plus 3, no repeats, got to use it. Y plus 5, got to repeat. So we're using this one and not that one. Again, they're repeats. And then y minus 8, we've got to use that one as well. So our final answer here, our LCM, is as follows. Y squared times the quantity of y plus 3 times the quantity of y plus 5 times the quantity of y minus 8. Not asking you when we get into the algebra stuff to multiply them out like we did here with these numbers. Just list it as it is. That's your LCM. One side note. Let's say, and again, I'm just making this up, so hypothetical. Let's say as we work this out, we had y squared, y plus 3, the quantity squared, y plus 5. So the only thing I'm changing is that right there. Check that. I don't want it there. I want it on this one. That'll help my example a lot better. Let's say those were our 2 factor things. So the question then is, you look like there's repeats here, just like with variables. Use the greatest power or highest power of each factor. So I would have to use this. I'd use my y plus 3. Here's y plus 5 to the second, y plus 5. Use that one, and use that one. And again, we're not going to expand these back. There's no sense in it. Plus, it'll help us in reducing the fractions as we move on. Okay, let's try some examples now and see where we're going to put this into play. In our next example, we're being asked to add 2 fractions. 4 over 5a to the third b squared plus 9 over 10ab. So, first and foremost, find our LCD. And from our previous examples, we're going to, again, some of these things you don't have to break them all the way down. What do 5 and 10 both go into? We know it's 10. Variables, we're going to use the highest power of each one. Now notice these are monomials, so I didn't have to use factoring patterns. So a to the third and b squared. That's what we need to accomplish. So how do we get there? Well, to go from here to here, what has to change? Well, got to multiply by 2. A cubed? Nope. B squared? Nope. So I got to multiply the denominator by 2, numerator by 2. From this one to get to that, what has to change? Well, coefficient's 10, so I don't have to worry about that. I can need an a cubed. We got an a, so I have to multiply it by a squared. Got a b squared, got a b, so we got to multiply it by b. What you do to the bottom, we got to do the top. So what's this give us? Up here, we get 8, denominator 10, a cubed, b squared, plus numerator 9a squared b over 10a to the third b squared. So what do? Well, just like adding fractions, the denominator stays the same, 10a to the third b squared. We add the numerators. Now, there's no like terms here, so we just add them together. And we have that. Now, before you start saying, well, I can cancel these things out, there's a sum up here. You're going to cancel things out when there's a sum or a difference. It's got to be all or nothing. Final answer. And that's what we have. And we walk away from it. All right, let's look at this next example. Here I'm going to give you (3a squared over 16b squared minus, sure, got to get a subtraction problem in here, 8x over 5, sorry about the writing. Frankie, judging my writing on the video. So let's go. What we're going to do for an LCD, we need something that 5 goes into, we need something that 16 goes into. As we break all that down, you know, you go 2 to the 4th times 5, it's going to be 80. And then we look, what do we need in terms of denominator? Well, highest power of each variable. There's an a to the third, b squared and b. There's what we got to accomplish. That's what we need. So let's get there. So what do I got to do here? I got to multiply by 5. B squared's covered, but a cubed. And I got to multiply this. Once you do the bottom, we got to do the top. How do we get from here to here? Well, it looks like a 16. A cubed is covered, but we got to get up to a b squared. So we're going to multiply by 16b. And again, once you do the bottom, you do the top. Yes, that is not a typo. That is supposed to be an x before you think different. So what's this going to give us here? We'll have 15 a squared times a cubed, a to the 5th over, well, there's your denominator. You really don't have to do all the work down here once you've got it figured out. Minus, this is going to give us 128 xb, again, over 80 a cubed b squared. Put it all together. 15 a to the 5th minus 128xb, denominator 80 a cubed b squared. Done. Deal. All right. Let's look at this example then, please. So far I've given you denominators that have monomials in the bottom of them. So let's see what happens when we get expressions. So let's go with this. Got x minus 1 over x squared minus x minus 6 minus 4 over 5x plus 10. Okay, challenge here is factor. We have to factor these things. So there's two ways of doing this. Some people will write it out over here, which I will because it's in notes. Some people will just factor and leave the factoring down here. Your call. Actually, I'll do it that way. Dude, come on. Excuse me while the cat takes over. Go on, dude. See ya. Thanks. So let's do it the second way. I changed my mind. Cat convinced me. So I'm going to factor this. -6, product, -1, sum. So it's going to give us the quantity of x plus 2 and the quantity of x minus 3. This is going to factor GCF 5, and I get an x plus 2. So as I look at that, I got to be thinking, right, what do I want for my new denominator? So I see how many different factors here. 1, 2, 3 different ones. Those have the same. Remember, repeats are only going to be used once. So we need this, this, and that as our new denominator. So I'm going to write that out that way. Again, leaving it where it needs to be in the denominator. So over here, I'm going to have a denominator of 5, x plus 2, and x minus 3. That's our common denominator. So what has to change in order to get to that common denominator? Big minus sign. What has to change? Well, let's look. It has to be a 5 quantity. I look here. There's that quantity. There's that quantity. What's different? Multiplied by 5. So I got to take this times 5 and this times 5. So 5 times my numerator. Again, I'm writing out a lot of steps here. I know. All right. So I look. 5, x plus 2, and then x minus 3. How is this one different with this one? Well, there's the 5s. There's the x plus 2, but I'm missing this quantity, so I got to multiply by an x minus 3 on bottom and on top. So I'm showing my work on everything I do right now. Now, as you know, the denominators don't change, so there's nothing that has to expand. We do have to change the numerators, so we got to expand them. So I'm going to have a 5x minus 5 minus distribute 4x minus 12 over our denominator. Well, let's get to work. You know my phrase, add opposite. I'm subtracting everything in that second fraction. So 5x minus 4x, x, negative 5 plus 12 plus 7 over our common denominator that we are not expanding. Our common denominator which we are not expanding. Now there may arise a case where, and if you want to do that, you're fine. That quantity might cancel quantity. It doesn't. Again, it's got to be quantities now because we are dealing with expressions. I'd like to go about 3 more examples here and let you go on your way. Sorry, this is a little bit lengthy, but it takes just a little time, a little bit extra time as we're doing the video thing with it. So in this scenario, 4x squared plus 21x plus 5 plus 6 over 12x plus 3. So what's the challenge here? Well, I gave you a factoring pattern that we got to remember a little bit. we know this, we can GCF this thing. And that'll give us 4x plus 1. Over here, AC method going on. So with the AC method, AC equals 20. We need two factors of 20. That have to be 21. Well, that's going to be 1 and 20. So we're doing my work down here. 4x squared plus x plus 20x plus 5. Why did I choose that way? I don't know. It just hit me. Here, factor out an x, leaves us 4x plus 1, factor out a 5, leaves us x plus 1. So, as we do this, man, starting to get mistakes here, be careful. We will have, as we work this, the quantity of 4x plus 1 times x plus 5. AC method. So, bring it back up here. 4x plus 1, x plus 5. So, what do we got to do? Well, let's look. We've got 1, 2, 3, 4 factors. Our LCD is going to take a 3, the 4x plus 1, which is repeated, and the x plus 5. That's what we need. So, up here, sorry. How do they differ? I need a 4x plus 1, I need an x plus 5. There, what's different? You've got to get a 3 times all of that. So, I'm going to distribute right now. Just make sure you're hitting them both. 3x minus 24. Okay, what's different over here? 3, check. 4x plus 1, check. Missing the x plus 5. Bottom, top, distribute. 6x plus 30. So, as I do this problem, I'm going to get a 9x minus 24 plus 30 plus 6 over our 3, 4x plus 1, and x plus 5. But the reason I'm doing this one is so we don't just write things down and move away. They're fractions. Check to reduce. Check to reduce. So I can get a 3 out of those, leaving us with x plus 2, 3x plus 2, my. Let's do this the right way. Leaving us with 3x plus 2, there we go. And then point I want to make here is I can factor out things that are multiplied. 3 is being multiplied. 3 is being multiplied. So the final answer. And I don't know if you've thought about it, but somebody's like, well, what about the stipulations? You know, in these scenarios, you're probably not going to have to worry about them because the directions will say assume no denominators equal 0. What are they telling you? Save some time, so you don't have to go through and do all that. What they're actually trying to tell us or help us out with. All right, 2 more examples. Again, I'll try to move here a little bit. They're called complex fractions, though, and there's something we need. Meaning, we got fractions within fractions. So let's look at this first example. I'm going to give you x over y minus y over x. And before you say, can I cancel those? No, it's a minus sign. But that's over y over x plus 1. And again, can't cancel those. Plus signs, minus sign. So at first glance, like, oh boy, what do? Approach the same way. Get rid of your denominators. Take care of this. Take care of that. So use LCDs. Use LCDs to simplify the fractions. So let's deal with the top. Here's y, here's an x. What's our LCD going to be? Well, it's going to be xy. So what are we going to have here? And now notice how I'm doing a couple things here. I'm starting to give you the benefit of the doubt and figure this out. So that's got to be an xy. So what I got to multiply by? An x. So I got to do the same thing up top. X squared. Got to be an xy, so I got to multiply by y. Same thing on top. Minus sign. Minus y squared. Let's cover the denominator now. Remember, that's a 1. What's our common denominator going to be here? X. Do I have to change anything there? No. But I'm going to multiply this by x and this by x. So we'll get y plus x. Now, is this a little bit better? It is. Notice instead of like 4 different things, we've got one fraction with one fraction. What does this symbol mean? It means divide. And from previous lessons, we don't like fractions within fractions, so write it out horizontally. X squared minus y squared over xy divided by, now I'm going to change it, x plus y plus x, commutative property, all over x. Keep, change, flip. Keep, change, flip. X squared minus y squared over xy. Change it, flip it. So now we're multiplying fractions. Notice factoring pattern here, difference of 2 squares. X plus y, sum, x minus y, difference. Allowing us to now, we can do some cross reducing. Why? Because it's a times sign. X times y, so I can cancel those x's out. Not doing it this way, doing it that way. Leave me with a 1 here. Quantity of x plus y, you can always slap a parenthesis around that. Cancel those out. What's that leave us with a final answer? X minus y all over y. All right, our last example, we have this setup. Again, complex fraction. Hopefully you can see that I can't factor this, I can't factor that. Okay. Just focus on one part at a time. So our LCD up here is going to be the x minus 9 and the 3x plus 2. How do we get there? Well, got to multiply that by 3x plus 2 and a 3x plus 2 there. So I'm going to put it all up there. 24x plus 16. How do we get from here to here? Now, that's a negative x. We're going to multiply by an x minus 9 here. X minus 9 there. Negative x. So minus x squared plus 9x. Be careful with that, please. Kind of same thing going on in here. It's going to be an x minus 9 and a 3x plus 2 common denominator So how do I get there? I gotta go in x minus 9. X minus 9. Distribute. 3x minus 27. This one, we gotta go by 3x plus 2. 3x plus 2. Plus sign though. So plus 12x plus 8. So let's clear some of the confusion out of this bad boy. Up here, I've got a negative x squared. I've got a 24x and a 9x. So 24 plus 9. Excuse me 1 second. Thank you. Plus 33x and a constant plus 16. All over x minus 9, 3x plus 2. Big division bar. Simplify down here a little bit. Alright, before the typos occur, let's go back. I want to have an x here. So how's that going to change things? That gives me a 12x squared there and an 8x. I apologize for that. I'm going too fast. But at least I caught it before it was all said and done. So 12x squared, 3x, 8x plus 11x. And then a minus 27. All over x minus 9 and 3x plus 2. Keep, change, flip. Keep, change, flip. So here we go. Keep the top, change the sign, flip the bottom. So drawing this out, here's what we're going to see. So I'll bring it over here. Negative x squared plus 33x plus 16. Quantity of x minus 9. Quantity 3x plus 2. There's the keep. Change it. Times. And then the flip occurs. X minus 9. 3x plus 2. And then our 12x squared plus 11x minus 27. So let's look. Factoring. Can we reduce anything? Because it's a times, and well, look, our quantities will be real nice here in terms of elimination. That quantity is being multiplied, so is that, that, and that. So I got a 1 here and a 1 here. So the next question is, can I factor? Find the easiest one. Not the easiest one. You got AC method. That one's going to take a little bit of time. Can I factor this? And again, it's a little bit of an AC, but think about it. It's going to be a negative 16. Can you give me two factors of negative 16 that add up to be 33? Well, you got a 1 and a 16. One's got a different sign. 2 and 8. 4 and 4. None of them are going to add up to be this. So, if I can't factor this one, there's no sense in trying to factor that one. So your final answer on this is going to be negative x squared plus 33x plus 16 all over 12x squared plus 11x minus 27. So yeah, so don't make it harder when you have to. Find the easiest one to factor. All right. A little lengthy in notes, but I hope it's worth it.